This is our second lesson of the week. Again, my brain, I guess, is a little bit frozen from this cold day. So there were two functions that I left out in the last lesson. So let's just quickly go over them. Trig, okay, we did sine, cosine, forgot tan. Sorry, tan, nothing personally against you. Okay, so tan is a little bit, did you ever notice that? Tan is a little bit like a hyperbola, okay? It has these asymptotes, okay? It doesn't have a horizontal asymptote. That's not a horizontal asymptote. No, because it actually goes to 0. But it does definitely have a vertical asymptote. Okay. I wonder if there's a relationship between a tan and a hyperbola. I bet there is. Okay. I don't know what it is. But anyway, so we've got, y equal tan x. So what is tan? Tan is sine over cosine. So you can imagine when cosine is equal to 0, okay, then tan gets into trouble. It goes all the way to infinity. Okay, we mentioned that. Okay, so when does cosine go into infinity? It's half a pi, 90 degrees. Okay, I think I did that lesson to you, and actually you were a little bit. I guess you haven't heard about it before. We always said that 1 divided by 0. We can't divide by 0. It's not allowed. Not allowed. You can't do it. But why? Okay, well. Because I think I did that little exercise with you. 1 divided by 1 is 1. 1 divided by 0.1 is 10. 1 divided by 0.01 is 100. 1 divided by 0.000. As I make that denominator smaller and smaller and smaller, I get a bigger and bigger number. So 1 divided by 0 is infinity. Okay, that's it. Okay? Now, if I go, and this is interesting, same thing as a hyperbola. If I approach it from the left, okay, so I'm getting 1 divided by 0.0000000 positive number, then it's going to blow up to infinity, plus infinity. But if I'm going from the right, okay, because on the right, cosine after 90 degrees starts to become negative if you think about it, okay? So it's going to be minus 0.0000, so it's going to blow up to minus infinity. Okay, here we go. This one you didn't learn in maths, but you did learn with me, okay? Remember these straight line, these V's, okay? These come from the absolute values. So initial one was just absolute value, okay? Which was something like that. And then we multiplied, and then we gave it a vertical shift. So we vertically shifted. So x minus p, in this case p is positive. And we can also multiply by certain a, okay, to make it the arms a bit closer or wider. And in this case, we probably gave it a negative a, okay, so it flipped it from a v up to a v down. But also, what are we missing here? We've got a vertical shift, isn't it? In this case, again, a negative q that pulled it down. So we've looked at graphs like that. Right, we finished with the graphs. Let's move on to the real lesson today, which is combination or composition of functions. Okay, suppose you here. Okay, so until now, really, it was all not much new stuff. Now we're finally starting something new, and that's composition of function. And I'd like to start with this function, okay, h of x. Okay, normally we use f, g, but let's use h. So look at this function, very simple, 2x plus 5. It's a linear graph, it's a straight line, okay, 2x plus 5. I can actually create this function by a combination of two different functions, composition of two functions. And if you think back in the days when you actually learned about function, they used to be like this. I don't know if you remember these kind of thing. I know my daughter does that in grade, she did it in grade 4. Yeah, even actually, I think my grade 1 daughter, Lila, does that. These things, you remember these spidergrams? These are function. If you never knew about it, these are actually function. So at that time, you actually did that. They didn't call it composition of function, but you've done that. I can combine it by two things. I can say, okay, first of all, take an x. Because what is a function? Okay, a function takes an x in. That's what I tell my grade 8. A function is a machine. It takes an x and it assigns it a value that we'll call y. Okay, so y equal to x plus 5. Okay, it's a machine. You take in a number, you put in a number, and it goes y comes up. Okay? Depending on the rule, you'll get a different one. Let's try and do it in two ways. Okay? Instead of doing straight away 2x plus 5, I can do it in a different way. I can take an x, okay, and spit out a y, which will be 2x. So just double it. Okay? That will bring me here. Then I can take that 2x, and I can then add another 5. Okay? And that will bring me into my y. So what I've done the same function, but in two stages. First I doubled it, and then added a 5. Does that make sense? Okay? How would I write mathematically without these things? I'll say, okay, look, I've got two functions. The first function is f of x is going to be, no, let's do g of x. So g of x is saying, give me an x, double it. G of x, 2x. Okay, double it. And then I'm going to make another f of x, another function, which will be, give me an x and add 5. Give me an x, add 5. Now, how would I use these two functions, right? Because these are the two different things that I did. I doubled it and I added 5. How would I use these two functions, write them in a mathematical way that will be equivalent to that? And I'll show you how you do it. What you're going to do is because what's the first thing we do? We do 2x, right? We're not adding 5 and then doubling. We first of all double it. So we're going to write g of x, okay? G of x, you can see it. And then the g of x will be the new x in here. So first of all, I will double it. And then I'll put it here and I'll add a 5. So I'm going to first operate. I'm first going to map x to g to x. And that's going to be my new x to this function. Okay? So f of g of x. I'll first go from x, you see that, to 2x. That's what gx does. And then I'm going to add the 5, which is f. Okay? So f of g of x. That's how we write it. So the x for the f is basically your g of x. First of all, we do g of x, and then we operate f of x. Now, another way of writing it, I just want to make sure I use the same, yeah, is f circle g of x. Just want to make sure I drew it correctly like they do it. Yes. Okay? So this is the same thing. So f, I like to write this way. Then I can see that the x for f is your g of x. But you can also write like that. And what I've done here, I showed you that h of x, the original function, 2x plus 5, very simple function, can be written as a composition of two different functions. Okay? That's the main thing. Okay? H of x equal f of g of x. Right, let's move on to some examples. We'll do a separate video for that, so I'll see you in a bit.